In the first exercise, we are asked to write a factorial function that iteratively computes the factorial. So we don't want to use a recursive call. We don't want the function to call itself. Instead, we want to do it iteratively using a loop. In the slides, you've already seen an example of a recursive implementation of factorial. The main goal of this exercise is that you know how to write a function. We chose factorial because it's a simple function to write. So let's look at the solution here. First line, of course, we want to include standard IO library that allows us to do printf and scanf. Next, we will declare our factorial function. So first we specify our return type. In this case, we chose an unsigned long. An unsigned long can store more numbers than an unsigned int. We do this because the result of a factorial is likely going to be a very, very big number. So you could choose unsigned int here. Just realize with an int, you have 4 bytes to store your number. And with an unsigned long, you have 8 bytes. Depending, of course, on your machine implementation. This might not be true on each machine. But so we chose an unsigned long as a return value. We chose unsigned int as a data type of our first parameter, and that one we call n. So we have a factorial function, return value, unsigned long, parameter, unsigned int, n. Next, we declare 2 variables inside of the function, 2 local variables, an unsigned int c, which is going to be a counter, and an unsigned long, which will store the actual result. The result that we will return at the end of the function. Great. Now, how does this function work? Let us first think, how does a factorial work? If we calculate factorial of 4, that's 4 times 3 times 2 times 1, but the times 1 is not really relevant, of course. Now you can write it in the different order as well. You could write 2 times 3 times 4, and that's the same thing. So how can we encode 2 times 3 times 4? This is factorial of 4, so n would be 4. Well, we could just write a loop that goes from 2 up until 4, or n, and each time it multiplies our intermediate result with that new number. So if we provide an n value of 4, result will be multiplied first by 2, then by 3, then by 4, and then the loop is done. In the end, we return our factorial. So this is a simple iterative implementation of factorial. The main goal here is that you realize, how do I write a function in C? Next, we're asked to ask our user for input, which we do with scanf. Scanf reads from the user input, or you can provide a format string to scanf, just like you provide a format string to printf. So first here we print to the user, enter a number, and then we wait for input. Now, the moment the user presses enter on its keyboard in the console, some input is sent to a buffer, and scanf will go look inside of this buffer for something that fits your format. In this case, we asked look for an unsigned integer. So look for a number, interpret this as an unsigned int, and then once you found that, place it in the address of n. So the second parameter of scanf is where the value should be stored, and it expects an address. It expects an address value, and at that location it will store whatever you wanted it to find. In this case, a number. So we reserved space in memory for storing an unsigned integer, which we call n. and we provided the address of the space in memory. We provided that address to scanf. At that space in memory, scanf will place the integer. Next, we just print the value of this integer, and lastly, we print the result of the factorial of n. Notice that we use %LU here because we're using an unsigned long. So LU is what we use for an unsigned long. Lastly, we return 0 from our main function to indicate that our program has executed successfully.